We give you a cordial and warm welcome to a new documentary. If it is the first time, I introduce myself. I am the engineer Hiddekel Morrison and I appreciate you decide to see this educational content. In a new installment where we will get to know the strangest planets, very similar to our planet Earth, the so-called superlands that exist in the universe and that we will be able to see like never before, thanks to technology. Let's see how the James Webb Space Telescope will reveal unlikely and unimagined worlds, where we will not know if there could be any type or form of life, different from how we expect it and know it. From the perspective of an engineer. Let's start. Super-Earths are giant planets, similar to our planet Earth but much closer to their star or sun. So close that a whole year lasts only a few hours. So close that gravity has locked one hemisphere into permanent scorching daylight and the other into endless darkness. So close that the oceans evaporate, the rocks begin to melt and lava rains from the clouds. This type of super-Earth and others with also peculiar characteristics, extremely hot and close to their stars or suns, despite not existing in our solar system, they exist with some frequency in our Milky Way galaxy. Let's see how those super-Earths will be deciphered like never before thanks to the James Webb Space Telescope. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology and the universe. Thank you for contributing to the creation of educational content. With its advanced technology, the James Webb Space Telescope will perform historic remote geology work from light years away, studying fascinating rocky worlds. What are the surfaces and atmospheres of the strange and varied planets that exist in the solar system really like? That is one of the many questions that the James Webb Space Telescope of the National Aeronautics and Space Administration, better known as NASA, is about to answer. With its mirror segments beautifully aligned and its science instruments undergoing calibration, the James Webb Space Telescope is just days away from being fully operational. It has already been defined in the James Webb Exploration Calendar that among the investigations planned for the first year are the studies of two hot exoplanets classified as super-Earths due to their size and rocky composition. For example, there is the super-Earth planet called 55 Cancri E covered with lava and the so-called LHS 3844b without air. Researchers will program Webb's high-precision spectrographs on these planets with a view to understanding the geological diversity of planets throughout the galaxy and the evolution of rocky planets like Earth. 55 Cancri E orbits less than 1.5 million miles from its Sun-like star, 125 times the distance between Mercury and the Sun, completing one circuit in less than 18 hours. With surface temperatures well above the melting point of typical rock-forming minerals, the day side of the planet is thought to be covered in oceans of lava. Planets orbiting so close to their star are assumed to be tidally locked, with one side facing the star at all times. As a result, the hottest spot on the planet should be the one most directly in front of the star, and the amount of heat coming from the day side should not change much over time. But this does not seem to be the case. Observations of 55 Cancri E from NASA's Spitzer Space Telescope suggest that the hottest region is offset from the side that most directly faces the star, while the total amount of heat detected on the day side varies. This illustration shows what the exoplanet 55 Cancri E might look like, based on current understanding of the planet. 55 Cancri E is a rocky planet nearly twice that of Earth in diameter that orbits just 0.015 astronomical units from its Sun-like star. Due to its narrow orbit, the planet is extremely hot, with daytime temperatures reaching 4,400 degrees Fahrenheit, about 2,400 degrees Celsius. One explanation for these observations is that the planet has a dynamic atmosphere that moves heat. 55 Cancri E could have a dense atmosphere dominated by oxygen or nitrogen, explained Run Yu Hu of NASA's Jet Propulsion Laboratory in Southern California, who is leading a team that will use Webb's near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, to capture the thermal emission spectrum of the planet's day side. If it has an atmosphere, Webb has the sensitivity and wavelength range to detect it and determine what it's made of, Hu added. Yet another intriguing possibility is that 55 Cancri E is not tidally locked. Instead, It can be like Mercury, turning 3 times for every 2 orbits, known as a 3-to-2 resonance. As a result, the planet would have a day-night cycle. That could explain why the hottest part of the planet is moving, said Alexis Brandeker, a researcher at Stockholm University who leads another team studying the planet. Just like on Earth, the surface would take time to warm up. The hottest time of day would be in the afternoon, not right at noon. Brandeker's team plans to test this hypothesis by using NIRCam to measure the heat given off by the sunlit side of 55 Cancri E during 4 different orbits. If the planet has a 3-to-2 resonance, they will look at each hemisphere twice and should be able to detect any differences between the hemispheres. In this scenario, the surface would heat up, melt, and even vaporize during the day, forming a very thin atmosphere that Webb could detect. At night, the steam would cool and condense to form lava droplets that would rain back to the surface, turning solid again by nightfall. Illustration comparing the rocky exoplanets LHS 3844b and 55 Cancri E with Earth and Neptune. Both 55 Cancri E and LHS 3844b are between Earth and Neptune in terms of size and mass, but more similar to Earth in terms of composition. The planets are arranged from left to right in order of increasing radius. While 55 Cancri E will provide insights into the exotic geology of a lava-covered world, LHS 3844b provides a unique opportunity to analyze the solid rock on the surface of an exoplanet. Like 55 Cancri E, LHS 3844b orbits extremely close to its star, completing 1 revolution in 11 hours. However, because its star is relatively small and cool, the planet is not hot enough for the surface to melt. Furthermore, Spitzer's observations indicate that the planet is highly unlikely to have a substantial atmosphere. While we won't be able to image the surface of LHS 3844b directly with Webb, the lack of an obscuring atmosphere makes it possible to study the surface with spectroscopy. It turns out that different types of rock have different spectra, explained Laura Kreidberg of the Max Planck Institute for Astronomy. You can see with your eyes that granite is lighter in color than basalt. There are similar differences in the infrared light that rocks emit. Kreidberg's team will use MIRI to capture the dayside thermal emission spectrum of LHS 3844b and then compare it to spectra of known rocks, such as basalt and granite, to determine their composition. If the planet is volcanically active, the spectrum could also reveal the presence of trace amounts of volcanic gases. The importance of these observations goes far beyond just 2 of the more than 5,000 confirmed exoplanets in the galaxy. They will give us fantastic new insights into Earth-like planets in general, helping us learn what early Earth might have been like when it was hot like these planets are today, Kreidberg said. These observations of 55 Cancri E and LHS 3844b will be made as part of Webb's Cycle 1 General Observer Program. General Observer programs were competitively selected using a dual anonymous review system, the same system used to allocate time at Hubble. The James Webb Space Telescope is the world's premier space science observatory. Webb will solve mysteries in our solar system, look beyond distant worlds around other stars, and investigate the mysterious structures and origins of our universe and our place in it. Webb is an international program led by NASA with its partners, ESA, European Space Agency, and the Canadian Space Agency. What do you think of that variety of strange exoplanets that exist in the universe? I read them in the comments of this video. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the engineer Hiddekel Morrison and I invite you to meet again in a future installment.